Let's get started. Hello, my name is Fred Iantorno. I'd like to welcome everyone to Tech Talk 360, sponsored by AirPro Diagnostics. Thank you to Lonnie Margol, Josh McFarland, Michael Quinn, and Team AirPro for making this all possible. Our goal is to present topics that you won't normally see in other webinars, and today we've got another great one for you. I'd like to turn things over to our great host, George Avery. Hey, George, you want to start
Right.
us off?
Sure. Hey, first of all, thank you, Fred, and welcome everybody, and certainly a big thank you out to AirPro for making this possible. You might notice that the better half is not here today. Jordan is on assignment. She had a conflict, and she's not with us today, and we sure miss her. I've worked with Jordan for a long time. We may not agree on everything, but she is always someone that I can call and get a straight answer. So when we see her, you can tell her all the nice things I just said about her. Of course, the only difference between if I can't make it on one of the calls, the difference is you would miss Jordan. So I don't know how that goes. George Avery here, past chair of CIC and also the NABC, the National Auto Body Council. Proud to have been be associated with both of those, and along with some other things in the industry. But I've got the pleasure of being one of your hosts for the Tech Talk 360. So here we are. So I think we're ready to go. We've got a great talk for you today, or a great speaker. We'll get into some details, but as you know, we do need to go through a little bit of housekeeping. And of course, housekeeping first starts with with the antitrust. And as I say every time, excuse me, if we say every time that it does need to be read out loud for some of you, especially our insurance friends, because that is a requirement. As participants of this webinar, we need to be mindful of the constraints of antitrust laws. There shall be no discussions of agreements or concerted actions that may restrain competition. This prohibition includes the exchange of information concerning individual prices, rates, coverages, market practices, and of course, claim settlement practices, or any other competitive aspect of an individual company's operation. So each participant is obligated to speak up immediately for the purposes of preventing any discussion falling outside these bounds. So I mentioned that we got that going for you. Fred and I will obviously be monitoring that. Excuse me, but if you happen to see something or hear something that you think is not good, you can use the Q&A feature to let us know. And to speaking of the Q&A feature, we'll be able to take questions. As you know, we don't take the questions live, so we think that's a little bit more efficient. And for today, we'll take our questions at the end. We're not going to, even though you can send some questions in along the way, we'll wait to the end. Now, before we, oops, let me just back up one more. We are going to use the Q&A feature. So at the bottom of your screen, that's how you would send a question in. Those do flow into Fred and I. We'll go through them. If there's multiple ones, we'll combine them. But we'll wait, of course, until the end to ask them, so Florian can answer those questions for you. All right. You can use the chat feature. Just be mindful that you who you're talking to. Sometimes you'll put something in the chat and you're pointing to some person and you may have sent it to everybody. So just be mindful of all the things associated with using the chat feature. All right, Fred, I'm going to go to the introduction. Anything I missed, anything for the good of the cause? Otherwise, we'll just keep rolling forward. All right, sounds good. All right, the topic today is the transition of the automotive industry into software-defined vehicles. So, we got a lot on our table, a lot on our plate to work on, and we're going to have Florian Rohde is with us today. He's a managing partner of iProcess based in Las Vegas, and he knows this stuff. And as we went through it, I had a chance to peek at the PowerPoint, and it's really good. And there's a lot of information in there. And I just want to make sure everybody that's listening, if you're repair facilities or stakeholder, whatever you do, if you're an insurer and you're on a Polycom and there's a bunch of you there, I do want to just please share with your friends. I think Tech Talk 360 has kind of done a very good job, not kind of, has done a good job in bringing some very unique and very timely information. And I know there's a lot of webinars out there, and I know your time is very valuable, but this is one that you want to make sure that you attend. So Florian's with us. Florian's going to take us through the process, and we're looking forward to, let me just advance that to make sure. Like I said, I'm going to advance that. It did not advance, but we're going to give Florian. So I'm going to welcome Florian to the call. Thank you so much, sir, for being here and taking time. I know you've done a lot with Simmons and with Continental, and of course, very active with Tesla, and did a lot with them. And I think from your chair, we're really looking forward to having some getting some good information. So with that, unless I missed anything, Florian, it's all yours.
Thank you, George, and hello, everyone. Fred, can you check with the screen control real quick? I'm currently just in view mode. I think you have to give us the controls back.
I think I gave it to you, but
Here we go.
okay. You got it?
Let's see if that works. Yes. All right. So let's talk about software-defined vehicles. So I'm from the R&D side of the automotive industry. I'm especially, from development, and I will speak from my perspective. And this is a little bit of a roller coaster ride, so bear with me. But I try to create a presentation in a way that it actually talks into also the aftermarket and the insurance and so on. But I'm focused, and I'm coming from the research and development side. So first, before I go into the details, let me introduce myself. And apologies, we have a little bit of a delay here because we had some technical issues. Let's see.
You were not advancing there. Let me see.
No, so okay, so let's see.
Okay, I just did. Oh, now we're advancing. Who's doing it?
I just clicked twice, so let me.
Every time there's a problem with this kind of stuff, I
How does it
realize
go?
that there's a lot of I wouldn't even meet half the people that I've met if it wasn't for Zoom. So I think in the long run, it's a good thing. You clicking along there?
I just clicked one. It seems to be very laggy.
That's not good.
No, that's not good. Maybe.
Hold on 1 second.
Yeah.
Otherwise, I'm going to advance and see if it advances quicker. Does not.
I'll do it for you. Don't worry then. Just
Yeah, in that case, just give me the entire slide. Or if you want to change real quick to the PDF, then we actually get the lag out, and that's okay too.
it says you can control.
Yeah, it says that, but
You try it now.
okay. Let's talk about this slide real quick, and then I think the problem is as soon as George is moving his mouse, he's taking the control from
All right, I have taken.
All right.
Here.
Okay, so I started my career about 20 years ago in the automotive industry at Bosch as a diploma intern, and then I started as a junior engineer at a company called Siemens Video. Some of you might remember that. We were building electric power steering systems, first generation, and a highly safety critical product, as you can imagine, because if you want to go left when there is no left, or if your car wants to go left and there is no left, that's a very dangerous situation. So we were building the first generation with functional safety built in. This company, Siemens Video, I was located in Frankfurt in Germany, and then we got integrated into Continental Automotive, and I spent some time over in Romania. We were building up a new location there and building power steering systems for Volkswagen and Audi. In 2012, I took an adventurous leap of faith, and I moved over to a startup called Tesla Motors. Tesla had just sold the first Model S the day before the interview I had there, And over at Tesla, I became responsible for the validation of the vehicle level software behavior for the entire vehicle, but also for the charging stations, for the customer products like Toyota and Smart and Mercedes-Benz, and all the other products that we were developing over at Tesla. I was there responsible for that topic for 6 years almost. And then after Tesla, I spent a year at NIO as a director of integration of their what they call smart components, their vehicle gateway, their infotainment system, and their ADAS system. And in 2019, I joined iProcess Consulting as a advisor and consultant in all topics about software-defined vehicles. I'm also holding advisory roles for Mitsubishi Motors, Digital Auto, and Destro Solutions. So now I'm clicking and let's see what happens. Wow, okay, that worked extraordinarily well. Talking about software-defined vehicles, or in general, the history of cars. So cars were invented, give or take, about 140, 145 years ago, and they were originally horseless carriages. So what we did is we removed the horse and we put actually some sort of propulsion unit into the vehicle, and we had a carriage that worked without a horse. The next generation came around in the 1920s, where actually the car started to look more like an automobile and less like a carriage. So we started to put a cabin on, maybe a heater, a roof, windshield wipers, and so on. But they were purely mechanical products for quite a while. And somewhere around the 1980s, we started a new generation. The microcontroller moved into the car. And we started what we call EE architecture, so electronics and electric architecture. And we had first motor controls and transmission controls. But over the years, basically every functionality started to be controlled by microcontrollers, and with that by software. Now around the year 2020, we start to see the emergence of what we call a software-defined vehicle. And I leave it to you if you call it the third or the fourth generation of vehicle architecture. But now we actually have the car providing features to the user and enhance the user experience by working together rather than having distributed components providing separate functionality. And we will go into this right now. So what does that even mean? What's our motivation? So what we can do now with the software-defined vehicle, we can have a continuous improvement of the user experience so that the car that I buy today will stay fresh, similar to what I know from devices like this, that I continuously get software updates, I get feature updates, and I get modifications, ideally to the better. What you see here in the picture is on the left side is my friend Christoph driving through the San Francisco Bay Area in a Tesla Model S in 2013. And you see a very original Tesla user interface there. The same car doesn't have to, it's not urgently the same, but can be the same car. On the right side, you see the version of 2018, which has a much fresher look and feel and a much newer, upgraded user interface. This is just a simple example. But the customers, the users because of the IoT and the telecommunication devices, they start to get used of modifying or improving user experience over time. And we in the automotive industry, actually, we get it tasked to take care for this as well. We have customer interactions after the initial sale. Originally, when I sell as an OEM, I sell a car, I'm done with this transaction, and the customer is never coming back to me. They come back to you, they come back to service, they come back to repairs, but they never come back to me as an OEM. And now I have the opportunity to actually update vehicles and vehicle functionality while the customer has the car already purchased. Maybe a customer didn't know about a feature when they bought the car. Maybe they didn't have the funding. Maybe the feature was not available. Over time, it can actually be added. And here you see an example of the Tesla mobile app where you can add an acceleration boost of $2,000, of 0.5 seconds for $2,000 just through your mobile app. I also generate new revenue streams because rather than just having initial sale for an upfront cost, I can start actually renting out features. There are good and and less good examples out there, but the approach works very well. For example, if I only have a short ownership of a car, maybe I want to rent a feature like this FSD capability rather than purchase it for a larger upfront money. So Additionally, the customer actually completes, or I can complete a feedback loop with my customer. Originally, what the car manufacturers do is fire and forget, and I never see my product again unless it breaks. So the customer usually doesn't come back after 10 years and tells me this worked well, this one I haven't really used a lot, and so on. Now with the SDV architecture, I can look into data and I can see how products are used and how far are they actually used in their useful life. And I give you a quick example. Some years ago, a friend of mine and I, we looked into the data of the Tesla front trunk. You know, Teslas have this frunk, and we looked at the data and we said, like, how often is that used? And we found out that it is used basically every day in the first 3 months and then pretty much not ever again. And we looked into that and we figured out, so in the first 3 months, you show your front trunk functionality to your friends, to family, colleagues, and so on. Then you put your tire kit and your mobile charger in it, which you usually don't need, and you're done with it. And so it's about 90 times that this front trunk is open, but it was designed for 10,000 times. So with that information, we could actually save significant amount of money while redesigning the next generation of that and still stay within the customer use case. Additionally, what you see there on the bottom left, there is actually a verbal feedback loop. So we hear that in the industry a lot, that it's about customization and we have to build what the customer needs and wants. But as a customer, very often you're missing a channel to provide that information back to the car makers. So this is one example. NIO has a different example. The NIO CEO goes in on a chat every Friday with customers, and you can tell them what you would like to see and improve on the car. So to actually close the loop and not only say we want to build what the customer wants, but actually to get customer feedback and build it into your future product. We have preventive maintenance, for sure, very interesting for people on this call. So instead of having the car breaking down, and I'm sure a lot of you have metrics how much it costs to bring a car in that broke down on the freeway versus to send somebody out for a preventive maintenance, for example, here to change the 12-volt battery. But it's not only the sheer costs of like towing a car and repairing and so on, and take a bay for that, but also the reputation and the customer satisfaction. So when this happens to me and I have the service come out and fix my car while I'm at work or while I'm in this call right now, I actually have no negative customer experience and I'm happy with my brand. If I break down on my way to work or with my kid to school and I have to tow the car in, I have to wait for a few days and so on, I have a very negative customer experience. So the preventive maintenance can actually improve both the costs, but also the reputation a lot. And then to avoid the physical recalls, this is just a random number there. But so a lot of problems are solved by software. That does not mean, and I have to stretch it, it does not mean they're caused by software originally, but they can be solved by software. And therefore, we can actually use this design of the software-defined vehicle to mitigate issues through software updates. All right, so this is for the motivation. Here are some numbers. So while I was at Tesla, we actually released about 150 versions of software per year. That does not mean that every car gets that many updates. A car gets an update between 6 and 12 weeks time frame, but we serve the worldwide market from our headquarter location. So we had car updates which were specifically for Hong Kong, or we had updates which were specifically for cars with 19-inch wheels in Sweden. So those things actually spread out. In general, there were 26 major software updates per year, which you can calculate. It's one every 2 weeks. And then we had small hotfix releases in the meantime, which is adding up to 150. Internally, we created 20 versions of releasable software every day. And we ran full vehicle tests twice a day, which adds up to 14 times a week in an automated fashion. So what's needed? This is just a word cloud, and I usually talk about all of this in this talks when I go much deeper into the technical side of things. For this particular audience and presentation, I'll look a little bit from a higher level, but we will still look into the whole machinery. How does a Tesla work internally to be able to crank out all those things and features on a continuous basis? Let's go through the process real quick. So first, Everything is driven through change management, and change management is pushed by a source. The source can be one of the following: product engineering. Product engineering are the ones in our company that look forward into how we want to make our product better tomorrow. Service engineering, and I'm sure we have a lot of people on the call from that side, those are the people dealing with the product of today and of yesterday. So they have valuable feedback about the real world usage and about customer feedback. The factory at Tesla, we were very, very close entangled with the factory. As a matter of fact, the car was supporting the factory on the software side during the production, and basically a rolling computer that goes through the factory and supervises its own production. The marketing team that will, reach out and tries to sell more cars through advertising. Regulatory changes. For example, you go into a new market or you have new changes in a certain market. Europe just had huge changes for cybersecurity, which driven a lot of change. Engineering itself, and this is a Tesla special thing. Inside Tesla, every engineer is allowed to speak up and make the product better. And I give you a very simple example. In 2013, I drove a Model S prototype up to Lake Tahoe for skiing, and I used the windshield wipers, and it was washing, then wiping twice, then take a break, and then wiping once again. And I couldn't see anything anymore because the third wipe was absolutely counterproductive. So I came back and I actually plead my case, and everybody agreed it would be better if we changed that sequence. And starting from next Thursday, every car in the world was only wiping twice after using the windshield washer. By now, they improved it furthermore, but that just shows you the power every engineer in the company has. With advanced development, those are the engineers. They're doing research and looking into tomorrow's products. The customer, as I mentioned just in a couple of slides ago, you can actually give direct feedback into the Tesla organization to incorporate. And then the management, and this originally said CEO, but I made it a little bit more general. So our CEO was and is very vocal to a point that we integrated his Twitter feed into our internal communication system just to incorporate whatever goes out on Twitter. Anyway, all of these sources have the right and the capability to file a request. A request is a ticket. Everything in Tesla works through a ticket. If you want to change something in the functionality, is a ticket. If you want to hire a new engineer, is a ticket. If you apply there, you become a ticket. If you want to change tires on a car, you file a ticket. Everything is driven by tickets. And this ticket gets down into a leadership committee. And I was part of the leadership committee. I'll show you in a slide who's there. And this leadership committee looks like this. So you have project management, you have upper management, which is here shown as the vice president. You have all the different components that are working on a certain product stage. And then you have on the right side, you have the integration and the validation team. I personally was like the orange figure on the right side in the validation team. This group comes together and it plans what is called sprints. So every 2 weeks, we release new software. That's a sprint. It is responsible for the release process. Everybody on this table is a signature under each and every release. It runs the change control, and it also runs the long-term planning. This group makes decisions as a group, and it makes it immediately so that the teams can actually take that decision and work on. So the decisions they make can be one of the following when there's a feature request coming in. They can say no. They can say we do it later and they park it. Or they can say, let's do it, go. And then it goes into a feature team. And this feature team is looking like this. So it's pretty much the same setup, but instead of having the heads of each and every team, you have the engineers working on the topic. And those engineers working on the topic are under the lead of the integration or system engineer. This is how it looks like in a little bit bigger. These are organized in what's called Scrum sessions. So they're standing together on a regular basis, sometimes daily, sometimes it's twice a day, depending on how the urgency works. They're responsible to integrate the whole thing. They write their specification, the requirements. They implement the software, hardware, mechanics. They integrate it together, and they are responsible to bring it all the way to the market through the factory and into the field. And they're completely responsible for the technical ownership of a feature. These feature teams can live for days or months or even longer. It depends on the size of the feature. So a very short feature only lives for a few hours. The feature team, a very long feature, like when we did a dual motor propulsion system, that one was living for about a year, and it was also much bigger. So from there, when they're working on it, they work in those 2-week cycles in the software, and they work in 3-month cycles on the hardware, and they're synchronized in the middle through the integration department. And every 2 weeks, they are basically iterating through their software, and only, and this is very important, only if they are ready and can prove that through testing and validation, they can push it back down to the leadership. The leadership can have the following option now. They send it back to rework. They say that doesn't work as we want it. Or they say it's gotta go. And they put it in what we figuratively call our train card. And then every 2 weeks, this leadership team assembles a release train. And that release train is then going through the final validation. And everything that's in there is already fully tested. So it's not the first time it sees testing. If it fails the integration testing, the final acceptance test, it goes back to rework, one card. It's a modular setup, so the train can be reduced in size if necessary. If it passes, the train goes out, and it will go out. And the only thing that holds that can happen is if features don't pass, they get out of the train, but the train will go out every other week. And it moves over into the vehicle database, which I'll have a slide for later. And then you have a rollout and you have a monitoring. And I will go into that a little bit more into detail a few slides later. So this is Tesla's process on a single slide. Let's talk about configurations real quick, because this is where the software-defined vehicle can come in very, very powerful. So you have different variations of your product in the field, and I'm sure you all deal with a lot of those. So you have different platforms. Platforms like convertible, station wagon, sedans, they are defined by the OEM. They have a finite number so that the OEM knows exactly how many there are, and they can decide how many there are. And they're usually fixed for the lifetime of a product. Usually they decide at the beginning, we will develop this car as a station wagon and as a sedan, and then they are done with that decision. And it is very perceived by the user. It makes a big difference if you go to a Home Depot if you have a station wagon or a convertible. And it influences therewith your user experience. Next is the variance in hardware. Hardware can create variance, as you see on that picture, maybe because you do cost down, you do increased power, or you do second sources or alternative sources. We saw a lot during the chip shortage about the third option there. So this is controlled by the OEM. The OEM decides what kind of hardware variants they want to create. But it's not defined, it's controlled. And there's an unknown number. Again, chip shortage, there's much more hardware variants came out of that than ever anticipated. And it's growing over the life of a product. So it will never be less than yesterday. Because the hardware that's out there, it will stay out there. And so it's either not or marginally perceived by the user on a certain platform. And it has either no improvement on the user experience, or if so, it should have only improvement on the user experience, no negative effect. Now comes software variant. What you see there is an old photo of an actual Tesla branching tree of 2014 of how we develop software. This is a result of many factors. You cannot control it, right? Software is happening on a continuous basis, so you cannot control it. It has an infinite number, depending on your religion, if you get close to infinite, if it's getting there or not. But it's uncontrolled, infinite number, and it's growing over the product life every day. And it may or may not be perceived by the user. That's in the hand of the software developers, but it can influence the user experience. So this is the variance, and it's very powerful if you learn how to use that. So what you see here on the left side is actually how a Tesla Model S is configured and how the car knows all this configuration and its variants. So this has two huge advantages. First of all, when I tell the car to run software updates, it knows exactly what software versions and hardware versions it has and what it needs to update. But then also it gives me feedback into my database. What kind of cars do I have out there? So as an example, in Europe, you have to update your cars for security reasons for 15 years after end of production. So that can be about 25 years from today. You have to run a software update. Most cars will be decommissioned at that time, but you don't know if you don't have this granularity of variant management and feedback. And if you don't know what's decommissioned, you still have to consider it existing, and you spend a lot of money on the validation of certain variants, development and validation of software for certain variants that might not even be out of there. So the digital version of that that feeds back into the server database actually helps immensely to plan all those efforts. What you see right on the right side there is how it is done at a German premium automaker. So it's a sticker that was there on the rear bumper inside at the end of line, and it's hardly machine readable, and I hear it's also not very human readable after a couple of years. So obviously you cannot really do any field queries or anything with that information. So what can I do with that? So I can provide information to the user that is relevant for the user. We all remember, let me click on that real quick. I'll remember here on the right side, the good old owner's manual, which says your vehicle may have this feature, or if you have that, you have to go and read this and that. Well, then on the left side, you see the Tesla approach, which is a very, very targeted release note and user manual that is only for the feature you have in your car, the functionality you have in your car, either because you paid for it or because you have a certain model year of car, and you're not getting quote unquote spammed with functionality you don't have in your car and you're not interested. All right, I'm taking a switch of gears here, and we look into over-the-air services. First of all, the Alpha and Omega, the mighty center of the universe at Tesla, is what's called the garage. The garage is a website/database that does absolutely not look like this. This is how ChatGPT envisions it looks like. In reality, the garage website looks like a 2005 MySpace page, for those of you who remember those. Probably because it was developed by the very same engineers who did MySpace in 2005. The garage is the center of all information in the company. It has a production and a development version. So we have our internal version, and then we have the whole worldwide fleet version. And it has all vehicles in there that ever been built by VIN, from VIN 1 all the way to what was built like 2 minutes ago. And it's anonymized, has nothing to do with the driver and the owner. It's just the VIN of the car and its data. And then on the development side of things, even all our test systems, our test benches, everything had a VIN, and we had it all in this garage database. It has all those configurations. So everybody working at Tesla can use this database and tell you right now how many red cars with 21-inch wheels we have in Texas. That is something you should ask any other OEM if they can answer you that question at all. Or how often did the door open over the last 12 months on an average car with a low capacity battery? All these kind of questions you can ask that database, as I said, in an anonymized fashion, and you get a lot of knowledge about how your product is released. It also has all the software versions and the status. The status is like, hey, this is software that is valid for your car or it's not. We did a little bit of pokayoke there, which is a Japanese approach, is like avoiding mistakes by not allowing them in the first place. So technicians in service, they will not have an option to pick what software to put on what car. The garage will decide, this is the car, this is the software you install there, and it will automatically actually do that. They came up with a kind of like an interesting approach. As soon as those cars roll onto the Tesla Wi-Fi, they will automatically pull the latest update from this garage page and install it onto their car. The technician just has stage it in the car. Technician just has to press install. Some early adopters found that out. It's funny enough, and they drove by the Tesla service centers every day just to grab a little bit of Wi-Fi and to see if there's any new software they could grab. It has what is called car logs, data lakes, as I mentioned before. So this is all the cars are producing usage statistics, and they upload that into what's called the car logs. And as I briefly mentioned earlier, it has what we call the vehicle heartbeat. So it tells me what vehicles I really still have out there. So Go out to any OEM and ask them how many cars from 2012 even do you still have out there. You only know the ones you have track record from the service centers, and you know very, very few that actually ended up on your lot again. But if you see a car decommissioned at a junkyard or anything, nobody really informs the OEM that, oh, those cars are not around anymore. Obviously, you can look into certain database for registration, but that doesn't tell you the full truth. And then you have the OTA front end. So OTA, update front end. At Tesla, everybody who's working in R&D for the R&D cars, and then also service engineering for the cars out there that are out in the field, with 3 clicks of a mouse, you can update a car. The first one picks the VIN, the second one picks the software version, the third one clicks update. That takes about 3 minutes. I have talked with other car OEMs and colleagues there, and they say this this process for an engineering car takes about 2 weeks. So that's a significant difference. Talking about the logging real quick, how that even works. So there are different parts in the car. So you have the embedded controllers, which is all your brakes, steering, turn indicators, all this kind of stuff. You have a vehicle gateway that collects all that information. And then you have your UI systems and your autopilot systems. All of this go through the modem into what they call the mothership. And that mothership then sends it over, and you create those logger dashboards on the right side. So here's basically how it works, and it's maybe a little bit too technical for the audience, but it's just this one slide. So you basically have all those logs coming out of every car, all the cars in the fleet, and it goes through that mothership into what we call a data tank, and it's just zeros and ones there. And then it goes through some smart tools that actually sort, cluster, and annotate all the data, and it puts it into this data lake. And you have access, by now, you have AI data crawlers looking over that, looking for patterns, looking for certain issues in the field. You have the research and development department, as mentioned before, and of course the service engineering, who has full access to that, as well as the service organization like garages and repair shops. And that actually connects us to the interaction with service. So you have the tool, which Tesla calls it the toolbox, which is the service tool for their service centers. And this is directly interconnected with the R&D, which leads then back to what we talked about earlier here as a source. So if you have an issue there, and that issue actually leads to a request for change, it will find its way right into this R&D organization. And then you have, this is a similar but different illustration. So you have an R&D organization, and it works directly with service engineering. And at the bottom, you have the service centers and the technicians using guided tools that to go and define and find issues. And if they run into a problem that they could not solve the issue, they have an escalation button that goes through service engineering, and service engineering can escalate it up into R&D if necessary. But we're talking about, like, ideally 99.x% stay at the bottom. Service engineering deals then with 99% of the 0.1%, and then only that 1% of the 0.1% finds its way back into R&D. But it's very closely integrated in the organization. Talking real quick about how the OTA and OTA software updates work. So first, they have what they call a universal package. And I don't want to go more into detail other than saying this means that there's only one software for every car in the world, and it contains all the different versions and options. And the car is smart enough, based on its configuration management, to pull the right parts and configurations out of that. But for me, on the validation side, I only have one package. Of course, I have a lot of variants to validate, but it's only one piece of software. I have a hardware diversity layer. This is very important for cybersecurity reasons. So no safety critical parts are directly connected to the internet. This is called a diversity layer, and that keeps hackers out of my embedded safety critical systems. I use signed packages. So if I have software sent to the car, you cannot copy that, modify it, and send it to the car and pretend that you are Tesla. That had happened in the very early days. And so we started signing those packages for cybersecurity reasons. There's something called a production fuse, which is very interesting. I don't want to go too much into detail here, but the signing of package prevent developing our software a lot. So we actually decided that cars which are internal don't require signing of the package. And the way they do that is kind of nifty. So at the end of the production line, there's one transistor inside the chip. They put an overcurrent through it and they burn through it. And as soon as that is burned, it has to take a detour through the signature, and it can never accept an unsigned package anymore. There's like a little side story. Not everybody goes that much into technical detail here. So we have the gateway manifest, which is actually what I showed you earlier. The car knows exactly how it was built and what it is. And it also updates that every time it runs a software update. So if you bring the car into service and you remove, let's say, version B of a door controller and you put in version X of the door controller, the car automatically updates that and automatically pulls the new software and the new integration down, and it doesn't have to have a manual step there. And then we binary diff this. What does that mean? It means that we take the old software that is on the car and we take the new software, and we just like put it on top of each other and look at what's the difference. And to give you some ideas of the numbers, Autopilot 2 was a 1.4 gigabyte package. And with the binary diff, just to look at the differences, we got that down to transfer only between 10 and 100 megabytes. It was a huge improvement on speed, but also in costs of data transmission. So looking into rollouts real quick, and we're approaching the last 4 or 5 slides. So rollout management. So it is very important that we actually plan rollouts and they do them in an organized fashion. I want to know which group of cars I want to address and which group of cars have the priority. This is important for the validation, but it's also important for the monitoring of the rollout. What you don't want is what we call a big bang rollout. CrowdStrike did that some time ago and got black screened on all the airports. We all remember that. So what we instead do is cumulative rollouts. So we have small, what we call waves. And these waves are getting bigger. But these waves can also be stopped at any point in time when I'm seeing something not working out well. And then over time, I'm actually addressing my fleet properly. And it's important not only to fire and forget, but also to monitor the actual installation right now, as well as the success. And I will show you in the last slide about what kind of failure modes are there. And that's it, the last slide. So failure handling. There's different ways actually software updates can fail. And they're very, very different for the user perspective, but also for the way you're handling them. The first, you have what we call an early failure. Excuse me. An early failure means the software update did not even make it into the car. This is usually a communication issue. Somebody drove out of cell phone connectivity or into an underground parking or something like this. So you have no customer visibility. The customer is happy because they don't know that they actually missed anything, has absolutely no impact other than he didn't get any new feature set. But they don't know about it because it doesn't even reach him. The next is the minor failure. So it comes over to the car, the customer knows there's something installing and hits go, is looking forward to the new feature set, but the update fails right away. And this can be a variety of reasons. Sometimes there's a compatibility issue. Sometimes there's a checksum issue, something like that. Anyway, the update just abandons right away. The customer sees it, is not too happy about it, but has absolutely no limitations. He or she stays on the old software version, and the new version is getting scrubbed, and a new update has to be initiated. So a minor failure, no limitations. Next is we have the moderate failure. Moderate failure means the update fails halfway through somewhere. So we have a certain incompatibility in the car. And then it's very important, is that a safety critical incompatibility, or is this actually a minor issue? If it's a minor issue, the customer will see it and he or she might get limited in driving. They might get limited in range for electric cars. They might get limited in power and speed, whatever it is, but it is allowed to drive that car. But very likely, this car actually has to see a service member, a service center member. And then the worst case situation, we have a severe failure. The customer obviously not happy, as you see in the picture, and the vehicle is grounded. So what does that mean? That means a safety critical component has been failing during an update, and the car cannot be moved with certainty that it is safe. The two at the bottom, moderate and severe failure, are very often actually not software issues, but actual hardware issues, bent pins, connectors not connected, dirty connectors, all this kind of stuff. or battery failures during the update, even though we do our best to filter those out up front by checking the health of the battery. These two on the right will actually require the car to be serviced either by a mobile technician or by a service center. And in statistics, very often this is an actual electrical issue that is surfaced through a software update. From percentage point of view, the vast majority should be at the very left, minor failure. This is not even anything that we consider a failure. It's just that there's a communication issue. This is not a problem, but we should be like 80% over there. And then we go all the way down to the right, and we should be 0.00001% of updates, somewhere in that area for severe failures. And as I said, in that case, we very likely have an actual issue with the car, and we will have to service it anyway. All right, so I'm handing it over for the forum. What you see here is actually, and Fred, you can take control away from me so you can navigate your screen now.
No, I'm good. I'm got a couple questions. We do have a question that came in. So thank you very much. That it was excellent. And I have three questions. We did have one question that came in. I'm going to ask it second because this question I had. My question was, does the fast updates cause confusion or frustration? And I think you answered that pretty well with images. So that me being a visual learner,
let me add to that real quick, because we at the beginning we had a lot of early tech adopters and they were like asking for a lot of fast updates. But by now Tesla delivers cars to the mainstream for a long time, and we actually learned that there is a fatigue if you update cars too often. So people don't want weekly updates because they get a feeling that they have a quality issue with their car. What we found the sweet spot is the early adopters or tech-affine people, 6 weeks. Normal people, quote unquote, 12 weeks. So quarterly updates, and the user can actually choose that in the display. They can say like, I want to have the cutting edge, or leave me alone for a while and then just come back on a quarterly basis.
All right, good answer. And then the follow-up is a question that came in from the audience that said, I really talked about, can the owner block data sharing? So you were talking about giving me an update download. I think what the question that Oscar had was going back. Can I say, hey, I don't want you tracking how many times I open a door. I don't like that. Yeah. I did show my front to all my friends, and yes, I haven't opened it since, but I don't want you to know that. What are your thoughts there?
So yes, you can block that, and obviously you will actually have a little bit less personalized updates that come your way, obviously, because if you don't know what you do, we can actually not tailor it for you. But the thing is, it's some sort of like a swarm data collection. So if individuals are opting out, we will still get enough information out of the group in general. So yes, there is a switch in the displays. You can opt out. Depends a little bit on the market. So Europe has very strict laws there. China has very different laws there. US has different laws. But yes, there are opt-out options. You cannot opt out of software updates, but you can decide when you install them. But there's legal obligations OEMs have to update software in certain situations. Again, market very different in different markets, but similar to a Windows update on your computer, you can also not install an update on your car, but it will start bugging you at one point.
Okay. Yeah, because I just think about my, we just had a recent update on our phone. And anytime I get an update, I just count to 10 because by the time I get to 10, my bride hollers, they just changed my phone and I hate it. And that kind of thing. So I can see it. And what you said about staggering every 6 weeks, once a quarter, whatever, or you have that control, it's neat. And thank you for answering that. Fred, did you say something?
Oh. Yeah, I have a question, and I'm repairing the car, and how do I know, and it's got one of these, subscriptions, and may have multiple subscriptions. So how do I know I'm fixing this, or how, I'm going to be fixing something and I don't know how it's going to affect another subscription because that subscription isn't turned on yet?
Yeah, so this is where this configuration management, and that's why I put in those slides there. that really comes into play. So the car has all that information for you. So even if the driver or the owner says, I don't even know what I have, your interface in your workshop will actually tell you exactly what subscriptions are there and how they work together. And the car reports that to you as well as to the server. So it's all interconnected at that point. So that's what I meant with the pokayoke. So you can't really do it wrong. Obviously, there's always an option, but there's the approach is to really make it as streamlined as possible in an automated, like curated fashion.
Well, thank you. Thank you.
So
Well,
the other question I had, I don't know, it's pretty generic, but is getting input from the consumer. So, there's that old, if anybody remembers the old quote that Henry Ford had, because when he first created the automobile, a lot of customers went, "Why didn't you ask me?" And his famous quote was, "If I were to ask you what you wanted, you would have said you wanted faster horses." That's
Yeah.
it. You don't understand where it's going. And so is there any frustration as you interact with consumers that go, "Hey, I want this," and and someone at at your level going, "No, you don't." And if you do
Yes.
that, it's going to, blah, blah, blah. Any comments about that?
Yes, and I'm also not the visionary product engineer. I'm the validation engineer. I try to break things, right? I'm not trying to envision the future. And when our design department came over to us and they showed us the next generation and so on, it's like, wow, I would never come up, neither as an engineer nor as a user. So as you remember that bubble with the sources, so the user is only one of those inputs, and it will not automatically be done whatever they ask for. But sometimes users have very good inputs, and this is actually what I'd like to underline, is that no, you don't have to build. And I don't know how many people are remembering the car Homer Simpson once designed, when he had the freedom to design whatever car he wanted, and it was terrible. So we don't want the users to design the product or tell us the requirements for the next generation of features, but to take into consideration some feedback and some ideas, consider them. That is the very important thing that we don't really see a lot in traditional car making.
Yeah, that's interesting. Okay. And one other thing I had was, is, and as I say this, especially because I'm on the insurance side, a couple of people are going to bristle for a second, but let me finish. And that is why, how many times in my career from collision repair through have I done something and said, why can't all the OEMs do it this way? Why is it so different? And then, of course, I ended up working for an insurance company, and anybody that works with insurance companies know that insurers all have different ways of doing things. So here, I'm
Yeah.
but
So
what are your thoughts there?
So one of the biggest reasons for that is what we call in our industry legacy versus greenfield approach. So if you look at a company like Tesla, they were actually not started by automotive people, mechanical engineers who were really into manufacturing and so on. When I said that earlier with MySpace, that wasn't a joke. It were literally engineers that did MySpace and they came over. We had people coming from Apple, from Hewlett Packard, from all this kind of industries, and they introduced all this kind of software first thinking. And then you look into what we call the legacy car makers. They're about 100, 120 years old, and they have a lot of traditions and processes, and they have a very hard time to let go some of those things that actually worked very well for them in the past. But they have to, because the customer is slowly changing. Some countries are changing faster than others. But the customers are getting user experience out of, as I mentioned, telecommunication, IoT, and so on. And they expect things like this from their car makers as well. The thing is, and I mentioned that, George, with you in a separate conversation once, unfortunately, there's no one little easy thing that you can tell to all of them. It's like, hey, if you just do that and focus on that, you will get everything I just told you, right? So it's the entire concept, the entire idea of the software-defined vehicle does not start with the car being electric, a large misconception. It does not start with being connected, but it's mandatory to be connected. It does not start with certain architectures. You can have all kinds of architecture. I can build you a software-defined vehicle also out of a diesel truck. This is not the challenge. The challenge is the entire user experience, and that includes the cloud that communicates, that mothership thing. It includes the R&D processes, that includes the product itself, but also the service experience. So all of this has to actually morph into the next generation together. It's not only one thing.
That was pretty good. Well, I want to thank you. We don't have any more questions, and I certainly appreciate you answering mine. Fred, I don't know if you have any other questions, and we're
we're
getting
good.
close to shutting her down and finding out when we're going to have our next one. But Florian, I want to thank you very much for your time. And of course, you know, as I do with most folks that I see on this, after they do a presentation, if I happen to catch you in the hall, I'll probably have 4 or 5 more questions, but I do like the fact that you answer them pretty well, and I think everybody benefited from it. And I know everybody's busy. And I'll just say this, Fred, I just want to wish everybody happy holidays, and we certainly miss Jordan. We miss Jordan. And Jordan, if you see this on the record, or on, you know, when it's up for everybody to see, focus on those nice things I said about you. So that'll be nice. But Fred, thank you very much. Thanks very much to AirPro. I can't say enough about their desire to bring you unique and good information. And I know you have a lot to listen to, but please tell your friends that this is good. I enjoy being part of it, and I really enjoy all the presentation. So with that, Fred, if you'd like to tell us when the next one is. There it is.
The next one will be held on February 18th of 2026. I can't believe it. It's happening. But anyhow, thank you, Florian. Thank you, George. Thank you, audience, for participating and for tuning in. Have a great holiday, as George said. Have a great holiday and be safe and have fun. Take care.
Happy holiday.
Thanks. Thank you.
Happy holiday.